Welcome to this explainer. Okay, if you're gearing up for your APIA exam right now and feeling the pressure of 4 weeks of dense Python concepts, I want you to take a deep breath. Seriously, think of me as your personal super TA today. We're going to conquer this material together by breaking down the core building blocks of Python and really mastering the art of debugging. By the end of this session, those confusing error messages and complex loops are actually going to make perfect sense.
So are you ready to debug your Python knowledge? Let's dive right into this. Mastering these fundamentals isn't just about passing a test, you know? It's really about shifting your entire mindset so you can actually communicate with the computer without pulling your hair out. The stakes are definitely high, but I promise the concepts are completely within your grasp.
Here's our roadmap for the explainer today. We're going to systematically build your skills. 1. Basics and logic. 2. Loops and iteration. 3. List comprehensions. 4. Modular Python functions. And finally, 5. Common coding traps.
Starting right off with Section 1, Basics and Logic.
You know, every incredibly complex program you'll ever write or even use is ultimately built on these simple, foundational units of basic variables and logic. It's like a building. If the foundation is cracked, the whole thing comes down. So let's rapidly run through variable naming rules, because this is an area where super easy points are lost. First, you can only use alphanumeric characters and underscores. Second, you cannot start a variable name with a number. Next, remember that Python is entirely case-sensitive, so a lowercase a and an uppercase a are literally completely different variables to the computer. But pay special attention to this last point. Never, ever use Python keywords like print or in as your variable names. If you name a variable print, you're essentially overriding Python's built-in print function. Your code will just throw these mysterious errors later on when you actually try to print something, and it will drive you crazy trying to find the bug.
Now we really need to talk about math operators. Notice how regular division with a single slash gives you a float, so 5 divided by 2 is 2.5. And this brilliantly illustrates the difference between regular division and our next two operators. Floor division, right there with the double slash, gives you a 2. It aggressively chops off the decimal entirely. It doesn't round up, it just truncates. Boom, gone. Finally, the modulus operator, represented by the percent sign, gives you the remainder of the division. 5 modulus 2 is 1. Let me tell you, modulus is absolutely your best friend when checking if numbers are odd or even.
Okay, so now that we have our logic set, think about this for a second. How do we repeat an action without rewriting the exact same code 100 times? Like, if I want to greet 100 users, I'm definitely not typing out 100 individual print statements.
That brings us to Section 2, Loops and Iteration.
Loops are essentially the core mechanism that lets Python do all the heavy, repetitive lifting for us. You basically have two primary tools here, the for loop and the while loop. Now, while both of them repeat actions, choosing the right one is entirely dependent on what you know before the loop even starts. A for loop is what you use when you know the exact number of iterations or when you have a specific sequence, like a list of names or a string of characters. You know exactly where it starts and where it ends. A while loop, on the other hand, is kind of like a sentry on guard duty. It just keeps running and running as long as a specific condition remains true, completely regardless of how many iterations that takes.
Now, things definitely get tricky when we put loops inside of loops, which we call nested loops. Let's walk through this step by step using I for our outer loop and j for our inner loop. Step 1, the outer loop I starts its first iteration and freezes, just holding its value. Step 2, the inner loop j now starts and runs completely through every single one of its iterations while I just sits there and watches. Step 3, only after j has finished its entire cycle does the outer loop I take a step forward to its next value. Then the whole process repeats. The inner loop j starts all over again from the beginning. Just remember, the inner loop always completes its entire life cycle for every single step of the outer loop.
But what if I told you there's a Python superpower? A way to take a clunky, multi-line for loop and condense it down into something elegant and lightning fast. Seriously, how do we write a 3-line loop in just one single line?
Which leads us perfectly into Section 3, List comprehensions.
This is the truly Pythonic way to combine loops, conditions, and list creation all into one incredibly efficient package. Now, what's really interesting here is how you can break down that syntax structure inside the square brackets. In a single line of code, this completely replaces the need to create an empty list, write a standard for loop, and then nest an if statement inside of it. It reads almost like plain English. Basically, it says, give me this expression for every item in this iterable, but only if this specific condition is met.
Let's actually compare them side by side. On the top, we have the standard way. We create an empty list called even nums. We start a for loop. We check if I modulus 2 equals 0. If it does, we append it. It works for sure, but it's 4 lines of code. Now look at the comprehension below it. Iterator I for I in range 10 if I% 2 equals 0. It does the exact same thing in one clean, beautiful line. In a timed exam setting, this not only saves you precious typing time, but it drastically reduces your chances of making a silly indentation or syntax error.
So, we're writing great loops and clean comprehensions. But what happens when our code gets massive? How do we avoid repeating these complex logic blocks all over our scripts? Basically, how do we write truly reusable code?
That brings us to Section 4, Modular Python Functions.
Functions are the ultimate tool for creating modular, plug-and-play code that you can rely on again and again without rewriting a single line. Take this piece of advice straight from our actual TA session transcripts. Always break problems into smaller logical functions. It makes your code modular, readable, and easier to debug. This isn't just a polite suggestion. This is literally a survival strategy for passing your coding assessments. If you have a massive block of code and it fails, finding the bug is an absolute nightmare. But if you break it into small functions, you can test each part individually and find exactly what's broken in seconds.
All right, let's clear up a massive point of confusion right now. Parameters versus arguments. When you're defining your function, you create parameters. Think of these as empty labeled boxes waiting on a factory assembly line. When you actually call the function later to do the work, you pass in arguments. Arguments are the actual supplies, the raw data that you're dropping into those empty boxes for the factory machine to process. So parameters are the placeholders, arguments are the actual data.
And right here, this is exactly where students lose the most points on functions, confusing print with return. Let's break down how this works. Print simply flashes a value on the screen so your human eyes can see it. But the computer, it immediately forgets it. If you try to save the results of a print statement to a variable, you get absolutely nothing. Return, however, actually hands the calculated value back to the program so it can be saved, modified, or used in the next step. So the crucial point is, unless the question specifically asks you to display text, your function should almost always be using return. Confusing these two will cause your code to just fail silently in the background.
Speaking of failing silently, you've studied the logic, you know the syntax, but what are the most common pitfalls actually costing students marks right now in the TA sessions?
Let's get into Section 5, Common Coding Traps.
Consider this your rapid-fire survival guide for the OPP exam, based on real, frustrating mistakes students make every single term. Let's run through these quickly so you don't fall into the same traps. First up, the dreaded base 10 error. This almost always happens when you're testing your code with interactive inputs and you provide a string of text when the code is trying to convert it into an integer. Always keep an eye on your test inputs. Second, infinite loops. If you use a while loop and forget to write the line of code that updates the condition, your loop is going to run forever and just crash the grader. Third, as we warned earlier, keyword variables. Don't name your variables list, string, or print. And finally, indentation errors. Python relies completely on spacing to know what code belongs to what loop or function. Literally one wrong space and your code executes at the completely wrong time.
And please, internalize this rule, like write it down. If your code perfectly passes the public test cases that you can see, but it fails the private ones that are hidden during grading, the grader is not broken. You're missing an edge case. An edge case could be what happens if the input is 0, or a negative number, or an empty string, or even if there's an unexpected space in the data. When this happens, don't just stare at your core logic. Start asking yourself, what weird, unexpected inputs could break my code?
So, as we wrap up this explainer, I want you to look at this final question. What single piece of Python logic will you master today to debug your way to success? Will you practice list comprehensions until they're just second nature? Will you finally master the difference between return and print? Pick one concept we covered, open up your code editor right now, and go write something awesome. Happy coding, and good luck on your OPRI.